First, we'll start our discussion with the leads scoring case study. And it's a very interesting use case. It's a very interesting use case, something which is a little different from all the typical classification and regression use cases that we have discussed so far. So this is a very, very interesting use case where we are trying to look at the different features of a lead, which is a prospective customer. A lead is basically a prospective customer. So you are looking at the different features of the lead, and based on that, you are trying to predict whether a lead will convert or not. So that is the overall objective of what we are trying to do here, right? So what is a lead? What is the meaning of a lead? So imagine you want to buy something. You want to buy something on, you want to buy a shampoo, or let's say you want to buy a course, or you want to buy a car. So the moment you want to buy something, you are a prospective customer, right? You are a lead. So from the company's perspective, you are a lead because you went to the company's website. Imagine you are trying to buy a shampoo, a very high end. Let's say there's a company, a small company on beauty products in India called Minimalist. The Minimalist actually sells all these, face serums and all that. If you know about the company, so let's say you're interested in buying one of their products. So what you do, you go to their website and you spend some time. You spend 5 minutes and you browse through the different products. What kind of products they have? You look at the descriptions. You look at the reviews. Let's say you call up their customer care and you're really interested to buy some of their products to try them. Okay, so the moment you do that, the moment you take these initial set of steps, you become a prospective customer. You become a lead for the brand. They are trying to sell something, and here you come. You're a customer who somehow discovered them. Maybe you discovered the company through some Google ads or through some kind of affiliate search links, and you are able to land up in their homepage. The moment you do that, the moment you call up their customer care, you become a lead. Okay, and now what the company is trying to do is they are trying to predict that what is the probability that you will convert. What is the probability that now you're a prospective customer, you're a lead, you're just a lead, just a prospective customer. It's like you're a window shopper. What is the possibility that you will actually end up paying for their product? That's the problem that we are trying to solve. So can we use machine learning to estimate that based on the different features of the customers? It could be something as simple as the amount of time you spent on the website, or let's say when you call up the customer care, how much time you spent on the interaction. So can we look at all these features of the customer, and can we predict how much time it will take, whether the customer will convert or not convert, whether you will end up converting into a paying customer or not? So that's the objective that we are trying to address. Now, what I will do is I'll take you to this, to this beautiful use case. This is just to show you a slightly visual, a picture in terms of what is going on, right? So whenever we are doing anything in machine learning, it is very important to relate to the big picture. Okay, what is the big picture? How things were before, how things were before we did ML, and how things are after we implemented machine learning in the process. And there has to be real business benefits, right? So if you think from this perspective, let's say we have a, a typical call center, outbound call center operation where there's a person who will, like in the beginning of the day, what happens is they will do some very basic analytics. They will collate the data from different third-party, data collection agencies, and this is like your typical, Bajaj Finance and all those kinds of companies. I'm not naming anything in particular, but you get like many of these spam calls through the day. Right? Somebody will randomly call you and say, "Sir, you want a personal loan? Sir, you want to take this collection? You want to buy our product?" Some random messages we will see, right? So they'll say, "Okay, we are offering a plot of land for some lakhs or something." Okay, so this is like, what you call as cold calling. Okay, I didn't even ask for the call. I don't even want to purchase something, but somebody out of nowhere ends up calling me in the middle of my busy hours, and they are wasting my time and their time because you are not even a customer interested to buy something. So much of the outbound calling and the calling that happens today is very inefficient, and I'm sure you agree, like it's very inefficient because the data that these guys have, it's not to blame them, right? They're given a piece of paper and they're given 100 numbers and said, okay, call them. And the targets are completely based on that. But it's a very inefficient process because the data that they have itself is very stale. Maybe some 10 years back, you would have taken a loan from some third party, NBFC company. And because some 10 years back you took a loan, the company thinks that maybe you need a loan today. That is not updated. So, just because they have you in their database, they think that you might, you will need to take loans all through your life. But they're not really looking at your real-time data in terms of your bank statements, in terms of your net worth. Do you really need a loan? Or maybe you're a person who wants to give a loan now. So are we really taking that into account? Maybe not. So this is the traditional process I've highlighted here. So start of the day, you get 100 leads. 100 leads are 100 potential customers who you need to call, and your team lead tells you that, okay, pick up the phone, call up these 100 customers, and approximately you're spending, let's say, 5 minutes per lead. Okay, some people will talk to you nicely. Some people will say, hi, hello, keep the call in 2 seconds, right? So average, let's say we are spending 5 minutes per lead. Okay. Now, because the process is very inefficient, you end up getting only two converts. It's a very inefficient process, and because of that, you end up getting only two converts. That's the problem. So look at the amount of cost. Look at the cost of the process. So you are effectively spending 500 minutes, right? 500 minutes is a lot of time, right? So 240 minutes is 4 hours, right? So 240, 480 minutes is 8 hours, right? 6, 6, 8, 8 hours. 8 hours, approximately 8.5 hours you're spending to complete these calls. And in those 8 hours, like the whole day that you spend in the call center, you end up only converting two customers. So much of effort you put in, right? And mind you, those 8 hours are not free. Of course, you are getting paid, but from the company's point of view, they are having to pay you for those 8 hours, right? So they are incurring a very high cost, right? Of course, we can debate about the cost and the cost structure, but whatever, they're paying for no reason. They're paying for a very inefficient process. They're paying you to make 8 hours worth of calls just to get two converts. And all the convincing, you will talk to the customer, say this is a great product, please buy, and somebody eventually buys. Now, what are we trying to achieve here? This is how it used to be. And obviously, from a slightly technical perspective, you can see there are lots of like so-called false positives. Okay, so this is the process that is very inefficient because there are lots of FPs, false positives in this manual process. There are 100 leads that you're getting in the beginning, which means that somebody thinks that these 100 customers will convert. These 100 leads will convert. So there are 100 predictions that you're making, but you end up getting only two converts. So there are 98 false positives. That's another perspective of looking at things. So this process right now, as we see, there are 98 FPs. So there are 98 such leads which you think will convert, but in reality, they're not converting. Because see, you are calling the customer only because you think that they will convert. Otherwise, like, why will you call, right? So you think that they will convert. So the manual model that we were using before, there are 98 such predictions where you think the customers are good and they might, sorry, the leads are good and they might convert, but in reality they don't convert. So there are a lot of false positives, and that is what makes the process very inefficient, right? So a lot of false alarms are playing out. Now, how will machine learning solve the problem? So we are trying to implement a workflow that looks somewhat like this now. All of you can see the screen. Now we have the same 100 leads, but this time the agent will not directly pick up the phone and call the customers. They will not directly call up the leads. It will first pass through a machine learning classifier. The classification model will assign a probability of whether the customer will convert, whether the customer will not convert. So it is like a predict proba. So instead of directly calling up the leads, you will pass it through a classification model, and using that, we will find out what is the probability of convert. And then we will use a conditional if else statement and say, hey, if that predict proba is more than 30%, 30% probability of conversion is extremely high in sales and marketing terms. So if we have a 30% chance of conversion, that means most likely these leads will definitely convert. So you will send it to one set of salespeople who are proficient in handling those kinds of end processes. So they are the ones who will, let's say, be ready with the documentation and other things, and they will not have to like spend much time in convincing the customer. So these folks will make the transition process very smooth. So you can directly buy the product and the documentations and contracts and everything, and they get free contracts, converts in the process. Okay, so there are like six of these leads where the probability of conversion is between 10 to 30%. Okay, and this set of leads we will send to another group of this set of leads we will go and look at another set of salespeople, and there is another set of leads where the probability of conversion is less than 10%. So we have a less than 10% chance of conversion, and because we have a less than 10% chance of conversion, so 90 of these leads are like that. So there are 90 of these leads where the probability of conversion is less than 10%. And because it is less than 10%, there's almost like no likelihood of conversion. So you discard these leads. Now we can debate about these threshold values. I'm just taking a ballpark number, but typically in the real world, this number will be much lower. Because even if you have like a 1% chance that a lead will convert, you still want to take a chance and call the lead. So maybe this number will be as low as 1% in practice. So only if it's less than 1%, only if the probability of conversion is less than 1%, only then you will discard the leads. Because when you discard a lead, you have to understand that you're straight away losing business. So before you discard, you want to be very sure. You want to be very, very sure that, hey, I think this customer definitely will not come with us. So in other words, you can say that the false negatives are very costly. Especially for this particular problem statement, false negatives are very costly. Model predicted you will not convert, but in reality you convert. That is absolutely unacceptable, because the moment you have a false negative, you are straight away making an upfront loss, right? So whatever be the cost of your product, if it's especially if it's a very high value product, imagine you're maybe just giving an example, you're selling a car. Now, obviously car sales channels may not be like this. I'm just taking an example. Maybe let's say you're selling a course, online education technology, edtech course you're selling. Some of these courses or the degree programs can go up to 2.5, 3 lakhs, right? It's a very high value, product or a course that you're trying to buy, and a false negative can be extremely costly. So, the classification model predicted the lead will not convert, but in reality it did. So that is unacceptable. So FP is still fine, FP is still okay, but FN is not acceptable. So that's why the thresholds will be, we'll try to put it as low as possible. Okay, but this is still a much more efficient process, right? This is still a much more efficient process than the above one, because we are able to. So for the company, it is like a win-win. It's a win-win for everybody. For the organization, it is like a win-win. So the organization ends up spending less money, so the cost is lower, and it also ends up getting more converts, so the revenues are higher, right? So if you think of discarding these 90 customers out of 100 leads, you're straight away discarding these 90 leads based on your thresholds. So you only end up with net 10 leads, and those 10 leads you're getting 5 converts. So you can see that you're only effectively making these 10 calls and you're getting 5 converts. Why? Because you're channelizing it better. That is the other benefit of using machine learning for defining a process flow, because you're able to channelize those leads better. So the same person, the same call center operator is not handling all the customers, but in this case you're finding out what is the probability of conversion, and based on that, that is given to different customers, right? So this is the way how you can streamline customer support using machine learning, which is, we are seeing a lot of that happening today generally. So another simple example could be, maybe the use case is more aligned with text data, but let's say you buy something on Amazon and you're very unhappy with the product or service. So Amazon has something called the customer calls and chat feature. You don't need to necessarily call them, you can directly chat with them, and a lot of these kinds of models can potentially be leveraged. Okay, I'm not saying that they are exactly being leveraged, but I'm saying there's a huge potential where, let's say, you directly start out saying that, okay, I'm very unhappy with the product. I bought this yesterday and this item was missing, or this product seemed to be second-hand, and you're very frustrated. So you write, let's say, 3, 4 paragraphs, and in the chat, there is some kind of classification model that is being used. Okay, there is some kind of classification model we are using behind the scenes, which is looking at the text message and it is trying to predict the sentiment of the user. So based on the message, it is trying to predict the sentiment. And if it predicts a negative sentiment, if the sentiment is negative, maybe that chat will be automatically transferred to an escalation panel. Okay, if you're not that agitated, if you're not that negative, if it's a moderate or a neutral sentiment, then it will be sent to the regular process flow. Okay, so these are some of the ways how machine learning can also be used for for channelizing the different cases and channelizing the workflow in a better way. So if the probability is higher, if the probability of negative sentiment is higher, we'll send it to an escalation team. And if the probability of negative sentiment is lower, if it's a positive sentiment or a neutral sentiment, then we'll send it to the normal flow. Okay, so there are a lot of potential avenues how this can be leveraged. So now coming to the exact exercise, this is the leads data set we have. So that's the leads.csv file, and you can see this is the real data. Every single row corresponds to a lead, and we have the different features of a lead. Okay, so you can see every row corresponds to one lead or one prospective customer. So we have the origin, the lead source. These are the different features: total visits, total time, lead activity, country, specialization. So all of these are the different features of the lead. And on the basis of that, we are trying to predict the converted status. See, there's a column called converted, and this is what we are trying to predict. Okay, so converted can be either 1 or 0. Okay, now you might be wondering, how is this data even coming? Where is this data coming from? This data is coming from the historical context. So what you are seeing on the screen is purely historical data. Okay, so this data is coming from the historical context. So you already have a lot of data available for past customers, and you know that leads like this, right? So somebody who was, let's say, browsing the website for a long time. So leads like this are more likely to convert, whereas leads like this are less likely to convert. So you already have this data from the past historical context. You have studied the marketing campaigns over the last 2 3 years, and this is how marketing campaigns go, right? You you advertise your company, or you advertise your product on Google or different marketing platforms, and you see the inbound visits that are coming, how many customers are coming to your site, what is the conversion ratio. So that is how you collect your label data. That is how you collect your XY combinations, right? And once you know that, okay, leads like this they converted and leads like this they did not convert, once you have that historical data, once you have that label data, now you can build a classification model. Okay, and the other things we will follow the same way, like we do the pre-processing, feature selection, all those are part of the process. But now you'll build a model, and next time you have a new lead, next time you have a new customer, you will try to predict whether that customer will convert or not convert. So based on the historical data, you build a model, and next time we have a new lead or a new customer, we will try to predict whether the lead will convert or not convert. So that's the way how we are looking at it. So this is the data dictionary where I've defined the different features, and all of you, you had enough time to go through this already. And here we have actually solved the problem. If you see, this is the notebook where I've already shared the entire end-to-end solution. So this part is easy, but the core objective of this exercise, the new learning, the key learning that I wanted to discuss here was just a case study, just the business aspect of things. Okay, so whenever you're doing machine learning, don't just try to focus on the technical solution. The technical solution is in many ways easy. You have a data set, you know X, you know Y, you have all the methods in your repository. That's the easy part. But your projects will not even start. Your projects will not even get funding from the stakeholders if you are unable to justify the value of machine learning. So in many ways, that part I would say is far more important, where you have to define the value. You have to explicitly state what is the value that the machine learning project brings to the table. So that's a very important thing to basically keep in mind. Okay, in this case, there is a very clear value that you can justify. You can say that, okay, we have managed to, by implementing machine learning, we are able to uh, achieve a very high return on investment. So initially there'll be a cost to set up the solution. You have to hire a team, you have to set up some hardware. So all of these are specialized tasks which need some initial cost. But if you can justify the returns on investment, if you can justify the cost reductions, then that part is also very important in ML. Okay, so even in the whatever be the business domain, it could be a healthcare use case, it could be a networking use case. Okay, it could be a data center use case. There are huge benefits that you can actually cite in terms of how machine learning actually helps. Okay, okay, so this is pretty much the solutioning we have done. And otherwise, I think after we have done the data pre-processing, this part is the normal approach that we followed. We are trying out different models. You can see we start out with a decision tree, and the decision tree we are getting around 80% and 78% accuracy. And I told you false negatives are very costly. The false negative means model predicted you will not convert, but in reality you do convert. So FNs are very costly. And this is the hyperparameter tuning that we can do. So with respect to a decision tree, we can tune the maximum depth hyperparameter. So if the smaller the value, the more underfit the model, and the larger the value, the more overfit the model. So remember, I told you on the first day that different algorithms will have different hyperparameters. Okay, so all the algorithms will have hyperparameters. Different algorithms will have different hyperparameters, and you have to tune the hyperparameters. You have to find exactly the right value of the hyperparameter. So that is the tuning that you will have to do here. Okay, and I think the good fit zone is coming somewhere around here. So when depth is equal to 6 or 7, I think this is where the cross validation score is coming out to be the highest. So the overall accuracy, the testing accuracy or the validation accuracy is coming out to be the highest, somewhere around here, 80%. So this is where we can say that we have the best model. So the depth of 6 or 7 is ideal. Okay, because if I have a higher value of depth, then beyond the point, the training score continues to become higher, whereas the testing score continues to fall. So this is the overfitting that is happening. So, and relatively, the model is becoming more and more overfit. Okay, that means on the training data, whatever textbook you have, it will do very well. But in the unseen question paper, it is starting to do very poorly. So this is what we can do. And now we are trying out different models. We are trying out a random forest. We are trying out different models to improve the scores.